So here we are at the Precision Matthews lathe, and what I want to do is go ahead and start working on the compound here to get our tool post mounted on the compound. This is what's kind of holding me up on being able to make some cuts on here. So this is a Multifix 40 position tool post that a viewer had given me a couple years ago. Been just kind of holding on to it, so we got it all cleaned up. I cleaned up all of the holders for it and got everything kind of ready to go. I will say that I noticed that the quality of this tool post and the holders itself, the bore and bar holders are the ones that kind of look a little rough. It's the quality of this particular manufactured holder isn't near the quality of the Pee Wee tools, or even especially the original Multifix type. I believe it's probably one of those that's it's just imported from China. I don't know who the make is though. There's no tag or anything on it. But I did get a few parts that I needed from Pee Wee Tools, including this handle here, because it was missing that handle for the cam lock. Some of the screws were messed up. The adjuster screws were bent, so I did get some of those parts for the other tool holders. So anyway, we're ready to get this mounted. So I'm going to simply do some measurements on our T-slot right here, make a drawing of the size of the T-nut we need, and we'll mount it like we did for the pacemaker. It'll be dogged off in here with a couple of set screws, but I think what I'm going to do, instead of making it flush and mounting this flat down on this compound, I think I'm going to make a little spacer that will actually fit the bottom. Let me take this apart. The way that I have them mounted on the Monarch and the Victor is that we have a spacer. Everything's falling apart on me now. Yeah, just move that stuff out of the way. Anyway, we have a spacer that's machined the same diameter as the bottom of the post here, that actually sits on here, and it centers itself up on the T-slot. And then, so it pulls down 100% on that spacer that sits in there. And I think that's how I'm going to do this one as well. But anyway, that's the project at hand. Let's get this guy mounted up. We'll have to make a stud for it so we can hold it down. And I think once we get that, we're going to be ready to make some test cuts over here on the new lathe. We brought the compound down to the home shop here. I'm just much better set up here with all my tooling to get this done more quickly and efficiently, while we're still continuing to build out the new shop and add tooling there that we need so that we can do jobs there. All right, and I was digging around my shelf here with all of my drops, found a perfect piece of material here, some 1" by 4" hot roll flat bar, perfect length. Probably go to the bandsaw and cut it down a little bit more narrow, and we'll use this to machine our T-nut for the compound. There's our milled T-nut. I still got to finish to the length and then put our holes in there, but I'll go ahead and test the fit here. Yeah, that's nice. Gave it about 5/1000 clearance so it wouldn't bind up. And we've got a little bit of extra room here because I'm going to machine that spacer that's going to sit on top, and I want it to center up in that T-slot there. That it gave me about 1/8 of an inch there. We'll go back to the mill, finish the links, and then tap our holes. So I'm going to be tapping a 5/8 hole there for our stud that we're going to machine. We'll also put a couple of small like 1/4 inch set screws on each side. That way I can just lock it in where I want it. All right, there's our new T-nut that we've machined. Got a couple set screws in there, 1/4 inch set screws, and those will be nice just to keep it set in place. All right, we've got our center hole tapped for 5/8 11. All right, so next phase I want to make my little spacer. It's going to sit up here that the bottom of the tool post here will sit on, and it'll be centered up on the slot there. That's what I gave myself about 1/8 of an inch there to center that up with. And then we're also going to machine the center stud for this as well. I've got this piece of 1144 stress proof off my shelf, and we'll take this piece right here and machine it so that it's going to center up on the center of the tool post there. All right, and then we'll use 5/8 at the top as well. What my plan is this is already bored out just over 5/8, and we'll use one of my 5/8 flange nuts here to hold everything down. All right. That's some 3.5 inch diameter chrome plated bar stock, old piece of hydraulic rod that we'll use to machine our spacer. Just bored it for clearance for 5/8. I got my fireball fixture set up in the vise here. We just got the disc or the spacer pulled down with a stud. Just kind of center up, and then we'll use the face mill to mill each side. We're just creating our step in the center that keeps it centered up on the compound. Be nice if I went the right way. This indicator is always the opposite of what you think you're supposed to be doing. Okay, this first cut didn't go as well as I had planned. I didn't look at the inserts close enough, and they were all kind of burned up on the corner and had some of the edge of it chipped away. That's why it was making so much of a burr there. So I've indexed all 5 of the inserts. Let's see if that's going to do better. I've also slowed it down and kind of decreased the surface speed here, running 660 RPM. 16th depth of cut. Let's see how that does. Get everything locked. Yeah, that's better. Making a nice chip now. Go back to the other side. I'm only doing half at a time. So we'll come back over to the other side and finish it out. All right, so there's our spacer there, and it's going to fit on here just like that. All right, and then we'll have our tool post. It's going to sit on there just like that and get pulled down there to it. So hopefully that spacer will work just as well as it has on the Victor and the Monarch all these years, and provide a nice base there, support to pull this down against. You can see the way they design these posts, they've got these deep grooves in there, so when it pulls down it kind of bites into the surface there and provides it a nice good solid footer to pull down against. All right, so one more component left. We got to go ahead and machine the stud. We've got our piece of stress proof there. We'll go to the lathe and start getting that machined. I got to do some measuring, make a little sketch, and then we'll start machining the stud. This is going to be turned to 32 millimeters. I'm just going to shoot for 1.258. Okay, so we've got one end done. What you guys saw me doing was obviously turning threading for 5/8 11 here, and I was showing you that I was using my thread pitch mic to measure the thread pitch diameter there to get it where it needed to be, and just using one of my standard 5/8 11 flange nuts there, making sure that it fits. This is actually going to be the T-nut side here. We got clearance to fit through the spacer on the bottom, and I got it to where we can screw it down. We'll probably mill a couple flats in this so that we can actually just screw this down, tighten up against the shoulder here. All right, and then it'll just slip. It'll just be floating in here. Other side's actually going to be turned and threaded for our flange nut for the top of the tool post. All right, so there's our tool post stud that we just finished machining. Only thing I'd left to do is just to mill a couple flats so that we can snug it down in there into the hole. But I want to go ahead and give all this just a test fit and see if I got my links right. And we've got a good fit on the thread there. So this should go down. It's not going to bottom onto the spacer here. It'll actually bottom out onto the thread. All right. And we got our tool post itself. Good fit on that. And I think I got my shoulder length wrong right here. I think I did. I didn't bring that other part in. Let me grab the spacer that goes there. I think I know what I did too, because I added a 1/16 there, and I think I forgot to take it away from this shoulder length right there. So I need to chuck it back up and just take a little bit off this shoulder. That way it's below this counter bore down in there, but that's going to sit in there like so. And then we have our 5/8 flange nut that we're going to use right there to tighten it all down. So it looks like I got everything right except for that one shoulder length that we just turned. So I'll modify that real quick. We'll go to the spacer and mill us a couple flats on there. That's looking pretty good. We're almost done with this guy. All right, I think we've got everything ready to put all this back together. So we went ahead and milled the flats. I made this 1/16", which is the same size of the flange nut that we used for 5/8 there. So 1/16 wrench. I'll have one of those wrenches there for the machine to use, but you can also use an adjustable wrench just the same. So I'm gonna go ahead and put a drop of oil on the threads there. Oh, doing that wrong. So we've got our spacer, and then we've got our stud. That is a good fit on those threads right there. Snug that down. All right, we've got our post. We can go ahead and put our clamshells on here. All right. I do not plan on drilling for the pin, by the way. That's what these other holes are designed to do. You can drill this. I believe it's, I don't remember what size that is, probably about a 10mm pin. But the purpose of these holes is that it actually, if you drill it and pin it, not only does it supposed to keep it from spinning under a hard load, it also doubles and triples the amount of equal spaces that you can do. So it goes from 40 to, I believe, 80, and then 120 positions, I think is how that's designed. I've just never used it that way before. All right, and then we've got this guy right here. It's going to go on. And then this is another piece that I got from Pee Wee Tools. The one that actually came on the tool post was hit or bent. And I had tried to straighten it out, and it just wasn't sitting flat the way I wanted to. It kind of rocked back and forth. So I was able to get this one from Peter. I need to do a little polishing on it there. All right, I did get a pointer and a spring from him as well for this. We'll put the spring on later once we have everything ready to go. All right, and then put a drop of oil on those threads also. And that will be it right there. Nice. Okay. Take our tools, drop one of those down on there. What did I do with the handle? That is a great question. I wonder if I didn't bring it down here. I must have forgot the handle. Huh. I must have left the handle at the other, but I'll grab one off the other lathe here. Just use one of my Multifix handles there. All right, that's going to be nice. Perfect. We are ready to put this back together onto the machine. We are almost ready to start making our first cuts there on the Precision Matthews lathe, but real happy with the way this turned out. This should be good, especially for what we'll be using a lathe for. You know, it'll probably mimic a lot of the type of work that you see me do on the Victor lathe, the one that we use to machine this, you know. So, I mean, I'm excited to try some aggressive cuts on it just to see what the machine will handle, but I'm not going to be over there removing metal like I would over on the American Pacemaker or the Monarch. But anyway, happy to have this on there. I love the Multifix type of tool post, and this is going to work real well for our needs there on the Precision Matthews lathe. All right, guys, we made it back to the new shop and back down here to the Precision Matthews lathe. I want to go ahead and see about getting our compound mounted up here and get this done. But there's one thing that I want to do, a modification I want to make to this cross slide before we mount the compound. So one of the things that I don't understand that was omitted from this design, this lathe design here, is not having another 0 mark over here on this side so that you can swing your compound around here. Like I like to keep it on 30 degrees for our threading, and you can't line it up because all you have is this one mark right here. There's nothing over here on this side to mark that. And on the way that they built this compound is that you only have 45 degrees right here. I mean, it's on both sides there, but if you wanted to swing this on around on the side and put it on like 30 degrees, like I usually like to keep it, there's no tick mark over here to line up on, okay? And since the dial doesn't go all the way around the base there, you can't line it up on this side. So I wanted to try to fix that by just making my own mark right here. We're going to scribe this. What I have done, this is an 18 millimeter hole here for the pilot for the compound. I went ahead and just machined one 18 millimeter and I milled it exactly in half. So we should be able to put this guy in there like that, right? We're going to take a combination square and we should be able to line this up and scribe us a line. I'll probably put one on both sides there. Just push it up against that pin there. And that should be dead nuts in the center of the rotation of that compound. So I'll grab a scribe, set the camera up, and we'll go ahead and mark us a couple tick marks there on each side there. We've got our the light for the lathe over here on too. That's the first time I've used it. It's a really blue light. So hopefully that's going to work out. We'll see. So let's put our pilot in there. Go ahead and get this done. I've got a scriber and I just plan on scribing it by hand. So I'm going to try to hold this nice and firm up against, make sure that we have our blade tight. We do. That should be, if I'm doing this correctly, this should be in the dead 0 to line up on our 0 mark. So we'll go ahead and, what's going on with this now? I guess my scriber. All right, let's just go for it. It's trying to push back up into the pin here. I'm trying to scribe it kind of deep so that it lasts for a while. All right, we got that one. Let's go ahead and do this side over here. This is how it is on the Monarch lathe. You have 3 lines that you can line up. All right. Yeah, I think that worked out pretty good. That's deeper than the one that they put in there. I'm sure this is cast iron, so it's pretty easy to mark there. All right. Well, that's one little mod done, so this little trick worked out pretty good. Give it a coating with some of the 336. All right. Zero. That is perfect. Dead nuts on 0, 0 on both sides. That's going to work out great. Now We can swing it around here on 29 or 29 and a half if we want to do our threading like I'm used to doing. So that makes me much happier. I think that's just that is a super easy mod that the factory that builds these lathes ought to do that and be able to give you, because not everybody wants to use the compound swung over here in this orientation. Sometimes we want it like that, or at least a lot of the people that I know like to run them that way. They need to give you the option anyway. So anyway, nice little easy mod that we were able to make. That's the other thing. It's so close, you can't really put the end of the wrench on there, so you have to use the open end. There's our 1 1/16" wrench. This is one that I picked up at Moultrie to keep down here. Tighten that up a little bit more. All right. What I'm going to do is get our, I want to get it set square, get a tool in here, and I want to get it set square in that position. This is the position that I like to use the compound in. And we'll square it up with the chuck and then set our 0 point there and then tighten it down. Those face of those jaws should be nice and square. Our pointer set to 0 there. All right, there we go. Just using a 17mm wrench for now. All right, our compound is mounted, and I think this thing's ready to start making some chips. All right, guys, I think our Precision Matthews lathe is ready to start making some chips. Our tool post is now mounted, and it looks good on there, and I'm excited about getting over here and seeing what this lathe will do and see how it'll handle. Apologize that it's been taking a little while to get to this. You know, it's just there's always projects, there's always jobs going on, and it's like I'm bouncing from one thing to the other. On top of that, I have jobs that's come in the shop that keeps me busy as well, and I try to get to these other project type you know, jobs in between those other jobs that come in. But anyway, this guy is ready, and you know, I've been trying to slowly fill out the toolbox right here. I keep bringing down tooling. Every time I make a trip down here, I'm trying to like think of some of the things that I just need to grab and put in a box and bring down here. And I'm trying to tool this up so that we have all of the tools here that we need, just like I'm used to at the home shop there. Everything's right there. I know right where everything is at. We have all of our different turning tools that we need, our threading tools, all of our tool bits, drills, center drills, just any number of things that are right there that have been established that I now have to get established here. And I'm trying to get this, you know, our tooling built up here so that we can, once we start working out of this shop too, we can start running it a little more efficiently. But until then, I'm going to be trying to gather up some tools to get over here on the machine and have the things that I need to get a job completed. Like I grabbed a few tool bits, you know, brazed on tool bits, right and left hand turning tools. I've got a threading tool, you know, things like that I've got down here. So I got the basics so I can get down here, do some turning. I've got a couple of measuring tools in here, some micrometers so that we can measure diameters. And I think the first thing I'd like to do, I need to get some material. I don't even have any rod stock or anything down here to turn. So I got to gather some of that up, bring it down here so we've got something to do some testing on. And I want to get over here, let's make some test cuts with it, see what it's going to do, what kind of chip it's going to make, see how the machine reacts, check our accuracy, see if it turns straight, if we need to do any re-leveling on it, adjust the tailstock, all those kinds of things. So that's what's going to be coming up very soon for the Precision Matthews. And I've also decided that we are going to come down here and machine our lead screw for the American Pacemaker compound. I want to use this machine and test this out and see how it's going to do cutting that lead screw, cutting some Acme thread over here. So that's the first job that I have lined up for the Precision Matthews lathe. We'll do some little testing first, then we'll get over here and we'll see how it does with the lead screw. All right, so that's it. We'll be back very soon to revisit this. Hopefully you enjoyed the video. Got plenty more projects. Hopefully you'll come back for some more, and we will see you later.